Bismillahirrahmanirrahim. In today's lecture, we will discuss the Pandas series. Panda is one of the most preferred and widely used tool in data manipulation and wrangling. It is an open source Python package used for data science, data analysis, and machine learning tasks. It also provides data structure and operation for manipulating data. It offers data cleaning, data normalization, data visualization, statistical analysis, loading and saving data, and much more. Data frame and series are two core data structures in Pandas. Series is a one-dimensional Pandas data structure, where data frame is two-dimensional Pandas tabular data structures. Pandas series is a one-dimensional labeled array in which labels are assigned to each element in the series, and it is capable of holding data of any type: integer, float, string, Python object. Series is just like a column in Excel sheet. To create a series, we need to import the Pandas library. Series can be constructed from Python list, tuple, dictionary, or NumPy array, or even scalar value can be used to create the series. So now to create the series, first of all we need to import the NumPy Pandas library and NumPy library, because we will use the NumPy library and NumPy arrays to create a series. So for example, data can be any Python list, tuples, or a dictionary, or even scalar values can be used to construct the series. So index is optional. If labels are not specified in the index, then values are labeled with the index number which start from the 0. Otherwise, if they are provided, so that label will be used as a for each elements. Data type by default for numeric it is int 64, so you can change the data type. If data type is not mentioned, it is inferred from the data. So let's say we have a data. So this is the Python list marks, and here we are going to create a series. Marks list is used to create the series, and we are also supplying the label for each element, and data type is int 8. Now to print, so this is the output of the series. If label are not mentioned, then index number which start from 0 will be used for every element, and also data type will be inferred from the data. For example, we have S3, another data dot series and marks. Here we are not mentioning the label index, so it will return the series like this one. So default type which is inferred from the data. Similarly, we can use the Python dictionary to create a series. So here we have a Python dictionary. This is the Python dictionary in which keys are the city's name and their values represent the temperature of that city. So let's say we create a NumPy series from this one. S4 is equal to pd dot series temp. Now to display this series, so we have a so in Python dictionary, if the index is not specified, then dictionary keys are taken to construct the index. Otherwise, label in the index will be used. So here keys have been used as a label for the each element in the array. If you can mention the index, for example, to control the output. For example, we want to just two elements, so and this, so it will return the data related to these two labels. Similarly, if we have a numpy array, for example, here is a numpy array which contains 4 elements. So we can also create a series using this f4 pd dot series and companies. Print S4. So this is the series. So as we have not specified the labels, the index, so here index number is used as a label. So we can also specify the index, for example, index equal to like this one, m for the first element, t and h, the last one is let's say n. So here this label will be used like this one. So in this way, if we want to construct from the scalars, so let's say S5 is a series, pd dot series, and we are going to use the scalar this, let's say this b is another label, and c. So creating a series from scalar, the index must be provided. Index must be provided, and the scalar value will be repeated for matching the length of the index. So in this case, the value 10 will be repeated 3 times because the length of the index is 3. So let's say 5. So in this way we can create a series using the scalar values. To import the data into the series instead of data frame, so we can use the 2 additional arguments, use columns and squeeze, to get the data. For example, we want to create to retrieve the data like this one. So this is actually a 2-dimensional array in which there are 4 columns, first row, and the other 3 represent the subject marks. So now we want to retrieve this data to store in the series, for example, but it is not possible because series can store only the single column. By default, when we will use the pandas methods to read the CSV file, this is actually CSV file, so it will return the data frame. So we can squeeze the data and we can select a particular column in this way. For example, here we want to retrieve the data. Here is we have a data, and pandas read CSV. So by default it will return the data frame marks .csv. So just to print, so now in this case it will return the data frame. So this is actually data frame. Now to create a series from this, we can use the additional attributes to arguments. Additional arguments use columns equal to, for example, we want just the maths column. Maths and quiz is equal to true. So now this is series. So in this way we can select the desired column from the files. Now retrieving elements. So to retrieve the elements from the data, for example, for above data, we can retrieve the data 0, for example. So it will return the value stored at the 0 index. Similarly, it also supports the slicing 10. So it will return the values from 0 to 9. It will return the 10 values. If we want first 6 element, so it will return the 6th element. In the same way, we can use the label instead of the index number. For example, in this S4, so we can use the if we use the, let's say S4 is a if we use the index number, so it will return the Toyota. Similarly, we can use the label here, so same value will return. So we can use both the labels and index number, so it will return the same values. So we can apply all the slicing concepts on the series to retrieve the elements. Now the next is series attributes. Attributes basically is used are used to find information without manipulating data. For example, if we use the S4 dot values, this attribute, so it will return the values. In the same way, we can use the index to get the index of the, so these are the index of the S4 series. Now to the other series about marks, S3. S3 is a series which contains the numerical values, SM values are repeated. So S3, for example, this is the series. Now to check whether values there is unique values. So S3 dot is unique. So false, because there is all values are not unique, some values are repeated. Similarly, we can check the data type. S3 D type is int 64. Similarly, size, how many elements are in the series. So we can use the size element. There are 7 elements in this, and shape, hand dimension, and there are some other attribute that can be used to get the information. Series also supports different methods that can be used for different tasks. So let we start with the head and tail. Head and tail are two basically methods. Heads return first return top n values. By default it will return the 5 values, and similarly the tail return the last n values. By default it will return the 5 values. So this is add. In the same way we can use the tail to get the last 5 values. By default you can change this if you want 3 values for example, so you can specify the numbers. Similarly data sum to get the sum of the values in the data. In the same way we can calculate the mean, median, product. There is another useful methods called aggregation, in which we can combine, we can give a list to the aggregation function to get the results. In the same time we can use more than one function. We can apply more than one function over the series, like for example data, here is aggregate function. So now we want to calculate the sum, mean and median for example. So in this way you can add multiple function to the aggregate function. So this is the results. Similarly we can count the values. For example in the above series, what series is basically S3. S3 is basically the series and which this is the S3 series already created. Now we will apply some methods over this series. Let's say S3 dot unique function. So it will return the unique values 4, 5, 3, 2. Although there are 7 values, but unique values are only 4. Just if we want to the number, so it will return the number of the unique values. Similarly we can use the S3 dot value count. So it will return number of occurrences of each unique value, like counts. So it is useful for seeing the distribution of the values. Similarly, to check S3 dot is not a number. So there is no not a number in the above series. If we want to calculate the sum of how many values are in the above series that are not a number, so there is 0 in our case. Similarly we can get the, for example n largest values. So it will return the n largest values. By default it will return the 5 largest values. Similarly n smallest value function be used. There are some other Python built-in function that can be applied on the series. For example, length.
if we want to calculate the length of the data is a series, so length is a Python function, it will return the length. Length is the same, it is exactly like the same attribute like of size attributes of the series. So there is type to check the type of the Python Pandas series, so we can use the data type. So type of the data, so it will return the type of that data. Similarly, to if we want to convert the series into the list, for example S3, so similarly we can convert the series into dictionary in this way. So there are so many other Python functions that can be applied on the series. In next video we will discuss the Pandas data frame. Thank you.